So just to review, remember these notes are a little bit different than 7.2. And so I want to go through these with you so that you understand. If you can prove that a quadrilateral has any of the following, and you only need to prove one, let's go through right now, and you might want to write this down because I think a lot of you can handle this. This is the easy part down here. The part up here is what you have to understand for the proof, okay? So, both pairs of opposite sides parallel. You might want to write that down, that this is the definition, okay? This is the definition. I'm going to zoom in here. Of a parallelogram. Now, we had that one already, so I'm just going to put a little check mark there that was one of the properties that we've already talked about in 7.2, okay? Both pairs of opposite sides are congruent. I'm going to put a check mark there just because in my mind, we've already talked about that, okay? I'm going to jump over one. The diagonals bisect each other. We've already had that one as a property, so that's review. Both pairs of opposite angles are congruent, okay? Now, which property have we talked about with parallelograms that you cannot use in a proof? That you cannot use to prove it? Because these are the 5 things that if you can prove one of these, then you have a parallelogram. What property have we talked about that is not going to be okay to use to prove that a 4-sided figure is a parallelogram? Does anybody see which one's missing? Notice there's 4 check marks in all the work you've been doing. There's been 5 properties. Which one's missing? If you don't know, take out your notes. Take out your notes for 7.2. Come on. Anybody know? You acknowledge. So I'm going to put a star right here, and I'm just going to write that you can't use that opposite angles, or sorry, let me change that. Consecutive angles. Consecutive angles are supplementary. Is that a property of a parallelogram? Absolutely. But just because you have that, here's why. Doesn't every quadrilateral have 360 degrees inside? Yes. Does every quadrilateral have to have consecutive angles that are supplementary? No. But some of them have that, and it doesn't necessarily mean it's a parallelogram. You can have that, and it could be a trapezoid. You can have that, and it could be an isosceles trapezoid. So I'm just trying to throw that at you. So these are the 5. And the one that I skipped over, these are the 5 that you can use like in our proofs and things to prove. You'll get on blurry here in a minute. So the one that I neglected, and I'm going to circle, and students mess this up all the time, so I'm going to draw a picture. And I want you to draw the picture too. Because believe it or not, you're thinking, this is easy. How do students mess this up? Okay? Right now off to the side of that statement, I'm going to draw a parallelogram. And what happens is you guys are going to have a lot of visuals. I'm going to be giving you a lot of pictures, and there's going to be some markings on your assignment, and it's going to say, is this a parallelogram? And if it is, you have to look and say, does it follow one of these 5? Could I prove it with one of these 5? And here's the deal. When it says one pair of opposite sides are congruent and parallel, here's what happens. I'm going to mark one pair of opposite sides. I draw this picture. One pair of opposite sides are congruent. See how I have them marked? But what happens is that same pair, everyone, has to be also parallel. So notice the same pair of opposite sides that are marked congruent are the same that are parallel. So for instance, if you encounter, don't draw this, do not draw this, I'm going to. But let's say you encounter a picture on your assignment today and you see this. You see this thing that looks like a parallelogram. Is that right there? Is this right there enough to tell you it's a parallelogram? No. This only shows that one pair of opposite sides are are congruent. That's not in our statement of 5. But what if it has this? Some students are like, yep, and I'm like, nope. This shows that this pair is congruent, and then the other pair is parallel. And that, y'all, is not what this new kind of thing is getting at, okay? So as we go through these examples together, let's make sure that you have the right answer, okay? What did you all say for A? Yes or no? What'd you tell me? Is that a parallelogram? Could you prove it? Yes, I see your heads nodding. So here's what you should have, okay? I already have it pre-written for you, so you're ready to roll. So check your work. We know that this is a parallelogram, and here's the deal. I checked. You know, you have to be careful because just because they're marked. So I made sure that is 75 plus 105, is that truly going to give me 360 all the way around? Yes. So therefore, one of the ways that I can prove that this is a parallelogram from up above is that both pairs of opposite angles are congruent. Okay, that's the only thing you can have. Before, you could have written, hey, is this a parallelogram? Yeah, because consecutive angles are supplementary. These add to 180. But that is a property, but not enough to make it like a true when you're proving. Okay, let's go on. For B, you should have no. Why? Because these diagonals are not bisecting each other. Because this piece is 12, we would have to know that that is 12 and it's marked with a 13. So right away, no way is this a parallelogram. And then finally on the front, the last one, you should have yes, and I think this was kind of an easy one. Because both pairs of opposite sides are congruent. Okay? All right, let's turn it over. And what I want you to do right now on your own, and I'm going to pause the video so people can do this, is I want you to do example 2 and example 3 on your own. I'm going to go out of order only because, so I'm going to, instead of doing example 2, here's why. What property, everyone, are you using to show or to solve for x? Which one from the front are you using? Oh, it's on frozen, sorry. There we go. We're not just doing algebra. If we were just doing the algebra, then, you know, I would make this problem a lot harder. Example 3, you have to know, y'all, the thing that I need you to understand is this chapter is not algebra. We're doing properties of parallelogram. That's the geometry. That's why you're here. So I need you to understand, I'm not worried that you can solve this equation. I'm worried that you recognize that you better know that the diagonals bisect each other. That is what I might ask you on a quiz or a test. Hey, don't solve for x, but what would you do? What's allowing us? So here's the deal. What is allowing us to take 5x minus 8 and set it equal to 3x? That's the equation. And I know everybody in this room can solve that. I'm not worried about that. I'm worried that you're not taking these properties and these ideas of how to prove it seriously, okay? So when I subtract 5x, or 5x, yeah, I'm going to get negative 8 equals negative 2x, and you should have solved and got x equals 4. I'm not worried about that in the least, okay? No big deal, all right? So that's really what I want you to look at, okay? Now let's go to example 2. In example 2, I always try to have students do this. And do you know what students tell me the answer is? I'm going to tell you right now, I usually have about 80% of my students who miss this question. Do you know that I have students who put 108 right here? And I'm not gonna like, you know, I don't want you to be like, oh my gosh, that's what I put. I put that 108. Why is this not 108? Kara? Thank you. It is your job to say how many degrees are in any quadrilateral 360. So if I take 360 and subtract 82, subtract 108, subtract 82, what did everyone get there? What is this missing angle? Did you do the math? You had to. What is it? 88. So this missing angle, so you all should have A is 88 degrees. And here's the work to get there. Now here's my question. Is this a parallelogram? No. Why? Because both. Do we have one pair? This is why these rules are important, because we have one pair of opposite angles are congruent, but the reason is both pairs of opposite angles are not. There's the symbol for congruent. Good job. Good, Kara. A lot of people just assume, because we've been doing this, that, oh, I'm going to slap a 108 there. Very, very good. So don't let those things trick you. You have to do the numbers. You have a calculator. It should be pretty easy to do. Okay? All right, let's go down. We're going to do these examples together, and then we're going to get on to proof so we can get this done today. Okay? All right, example 4. It says, what theorem can you use to show that the quadrilateral is a parallelogram? And when I say theorems, I mean the 5 on the front. Literally in the parallelogram looking thing, okay? So here we go. Part A, yes or no? Oh wait, sorry, these are not yes or no questions, my bad. We already know these are parallelograms. So we already know our answers are yes, as in, this is not, oh, I don't think so. It's saying, ooh, what theorem can be used? So which one on the front? Kylie, part A.
One side of the parallelogram is congruent and
parallel. Good. One pair of opposite sides are both parallel and congruent. Sorry. One pair of opposite sides are both parallel and congruent. Part B, someone else. Why would this be a parallelogram? Luce? Excellent. And this is kind of back to the easier things that we did in 1.2. But this one that, you know, we mentioned in part A, that's the new one. Both pairs of opposite sides are congruent. There's my symbol. And last one, well, 115 and 65 add to 180, but can we use that one? Can we say, is it true that these angles are supplementary? Yeah. But can we use that to prove? No. So here you would just use both pairs of opposite angles. My pen's dying. Opposite angles are congruent. All right. So this is just getting you used to using the 5 ways that you can prove that a 4-sided figure is a parallelogram. All right? Turn it over.